Welcome, tiny disaster. Somewhere out there are the deadliest bees on Earth. They already know you're here. Here's the thing though. One of them will follow you for a quarter of a mile to deliver a single sting. 10 times farther than any ordinary bee will chase you. You can run, it won't matter. Too bad, something just landed, and it brought friends. Today, you're going up against 5 challengers. Some will pursue you across an entire field. Some will cook you alive from the outside in. One won't even need a stinger. And the last one, well, we'll get there. Let's see who your first opponent will be. Challenger 1, Africanized honeybee. Good news, one sting from this bee is exactly as dangerous as one sting from an ordinary honeybee. Bad news, one sting is never one sting. One bee slams into your shoulder, you wave it off. Mistake. That single contact releases an alarm pheromone, a chemical signal that translates roughly to... Come here, everyone! This one. The venom from that first sting tells every other bee in range to sting that exact same spot. Your wound is now a target marker. You have been flagged. You look up, the hive entrance is moving. You back away slowly. Too slow. The Africanized honeybee crossed African and European species in the 1950s. Some escaped, spread across the Americas, earned a reputation. The twist everyone gets wrong is that their venom isn't stronger. It was never about the venom. It's about what happens after the first one finds you. One colony, up to 100,000 workers, most capable of stinging more than once. Do the math. Actually, don't do the math. It doesn't help. They pursue intruders up to a quarter mile, 10 times farther than a typical honeybee. You sprint, they follow. You dodge left, they adjust. You hide behind a flower. The flower does not help. They've been recorded staying on high alert for up to 24 hours after a disturbance. They're not angry, they're patient. There's a difference. The difference matters. You stay completely still inside the root cap until the buzzing fades. You didn't fight them, you outlasted them. That's the only winning move. Smart. You're covered in pollen now, though. That might be a problem. Into the hive you go. Before the next challenger, bee lore, quick. Every bee starts as an egg, hatches into a larva whose only job is to eat, seals into a pupa where its entire body gets rebuilt, wings, compound eyes, hard exoskeleton, then the adult crawls out. The eating machine became a flying machine. A queen spends her life laying eggs. Drones exist mainly to mate. Workers, almost all female, do everything else. They communicate using the waggle dance, turning body movement into a living map that guides thousands of sisters toward the exact coordinates of food. Together, they don't behave like thousands of insects. They behave like one enormous living thing. Remember that. Subscribe. Back to not surviving. Challenger 2, Giant Honeybee. Good news, you can see this one coming from a very long way away. Bad news, you walked toward it anyway because you thought it was a rock. The giant honeybee, Apis dorsata, is the largest honeybee species on Earth. It builds enormous open nests on cliff faces, completely exposed to open air. No protective outer shell, no wax covering, because there are no walls. The bees are the walls. Remove the bees and there is no hive. The colony and the building are the same thing. You're not looking at a home they built, you're looking at a home they became. Defense stat, off the charts. Territorial range, the entire cliff. And that cliff face has been occupied for potentially hundreds of years, generation after generation returning to the same rock. You're not just trespassing on a hive, you're trespassing on a centuries-old address. You take one step closer, the entire surface of the hive ripples, not randomly, in synchronized waves, thousands of bees flipping their abdomens in perfect sequence. Here's the part that should unsettle you. Nobody started the wave. No bee gave the signal, each individual bee simply responded to the bee next to it. Thousands of perfectly coordinated bees, zero planning, zero leadership. It just happens, every time, without fail. That was the warning. You take another step because you want a better look. It's genuinely rude of you. The defenders launch. The air becomes wings. You sprint through flowers that now feel like forests, not looking back, not slowing down, not making any more decisions that involve moving toward large things on cliffs. The shimmering was the warning, by the way. You watched all 4 waves. Into the hive you go. Challenger 3, Japanese honeybee. Good news, these bees evolved one of the most remarkable defense mechanisms in the animal kingdom. Bad news, you are standing in exactly the wrong place to watch it. A giant hornet lands outside the hive, one of the bee's most dangerous predators, capable of dismantling an entire colony. But the Japanese honeybee has spent thousands of years preparing for exactly this moment. They post lookouts trained to recognize hornet scouts. When one is spotted, a specific signal, different from the general alarm, travels through the hive. By the time the hornet reaches the entrance, the heat ball team is already assembled and waiting. This is not a reaction, this is an ambush. Hundreds of workers pour onto the hornet at once. They pile on, pack together, until the hornet disappears inside a dense buzzing sphere. Then the temperature begins to climb. The bees vibrate their flight muscles, turning the ball into a biological furnace. Inside, the heat rises to 46 degrees Celsius. The bees survive it. The hornet does not. The temperature of 46 degrees is not a coincidence. The bees survive up to 48. The hornet dies at 44. They operate in a 3-degree window between killing the enemy and killing themselves. Evolution found the exact margin and locked it in. Nobody calculated this. It just became true over thousands of years, which is somehow more unsettling than if someone had planned it. The bees on the outside of the ball take the most heat. Some of them don't make it. The colony registers this as an acceptable outcome. That sentence should stay with you for a while. It cooks alive, inside a ball of bees. Nature remains deeply unsettling. European honeybees were introduced to Japan. Same species, same environment, same predator. They never learned the heat ball. They still can't do it. The European bees meet the same hornet, and the result is very different. We don't need to describe it. You lean in to watch because this is genuinely fascinating. The bees nearest you turn around. You are roughly the same size as the hornet. Fantastic. The ball begins reforming. Around you this time. You push through the outer layer before the temperature climbs. You make it out. Just 46 degrees. You were in there for 3 seconds. The hornet lasted 8. Congratulations on outlasting a hornet by 5 seconds. Challenger 4. Stingless bees. Good news, these bees have no effective stinger. That's it. That's the whole good news. No stinger. You're fine. You breathe. You relax. You lower your guard completely. Classic. Over 500 species of stingless bees exist across tropical regions. No functional stinger. For the first time today, this actually feels fair. But here's what nobody mentioned. The resin isn't even theirs. They collect it from plants and store it in a dedicated armory inside the hive, specifically for defensive use. They built an armory out of stolen materials, with no stinger to back it up. Many stingless bee species also construct their entrance as a deliberately engineered trap. Narrow tunnels, angled approaches, resin-coated surfaces lining the walls. Anything trying to force entry gets slowed down long enough for the defense team to respond. They built the bouncer into the architecture itself. You walked through it. You're currently inside it. The first bee lands on your arm. You brush it off. 20 more land at once. Something thick and sticky begins coating your hands. Oh, you pull one hand free. The other gets stuck to your leg. You pull that free. Your elbow gets stuck to a leaf. It takes significantly longer than it should. And here's the part that makes it worse. Some stingless bee species make no sound in flight. None. No buzzing, no warning. They arrive, they work, they leave in complete silence. You would simply find yourself stuck and have to work backwards from here to understand what happened. Eventually, the resin dries enough to pull free. The bees finished their shift 20 minutes ago. The nest is quiet. You are covered in plant resin and personal regret. But you're out. We're counting that as a win. You're fighting nobody right now. We're still counting it. Into the hive you go. Every challenger so far has been one thing. One bee, one species, one threat you could identify, dodge, and in one deeply embarrassing case involving plant resin, eventually escape from. What comes next isn't one anything. Final challenger, the hive itself. Good news, you survived every challenger today. Bad news, none of those bees was ever the real enemy. Here's what nobody told you at the start. The final boss isn't one bee, it's the hive. More than 50,000 workers moving with a single shared purpose. Nurses feeding larvae around the clock. Builders shaping fresh wax into hexagons, the most structurally efficient shape mathematically possible. Guards at every entrance. Foragers traveling across entire landscapes and returning to waggle dance the exact coordinates of food to thousands of waiting sisters. The queen lays up to 2,000 eggs per day. Workers regulate the internal temperature to within 1 degree by fanning wings or clustering together. 1 degree across an entire living structure, maintained continuously. The hive has a thermostat. It is made entirely of bees. Your home thermostat runs on electricity and still gets it wrong. When the colony needs to choose a new home, scouts fan out, assess locations, and return to dance their recommendation. The more enthusiastic the dance, the better the sight. Other bees visit, form their own opinions, add their own dances. The colony holds a democratic vote, using choreography, and gets the right answer almost every time. You have a ballot and 2 choices and still struggle. Remember the stingless bees? The ones that trapped you in resin for 20 minutes while you fought nobody? Every single one of them was working for this. You try to find the single bee in charge. There isn't one. The queen makes 0 decisions. She lays eggs. That is her complete list of responsibilities. She does not direct foragers. She does not order defense. Every decision you assume she was making is being made by nobody in particular and everybody simultaneously. The colony has no leader. It has never needed one. You try to find a weak point. There isn't one of those either. You try standing very still and being extremely boring. The hive flows around you like water around a rock. It doesn't attack, it doesn't notice, it simply continues. Because against something this size, you were never a threat worth stopping for. Every Africanized bee chasing you across a field, every living wall on every cliff face, every heat ball, every resin trap, none of them was fighting for themselves. Every single one was protecting this. The hive has been doing it for approximately 30 million years. The waggle dance, the heat ball, the resin armory, the biological thermostat, all of it locked in tens of millions of years before the first human being drew breath. You are a very recent development. The hive is not impressed. Running won't defeat it. Fighting won't defeat it. Against the colony itself, survival is the only victory. Into the hive you go. The collection is finally complete. Killer bee, living wall, heat ball, resin trap, 50,000 bees in a single jar. Honestly impressive for someone who leaned into a living furnace because it looked interesting and spent 20 minutes stuck in resin fighting nobody. Now I know what you're all thinking. What kind of bee are you, Unhinged Kitty? Well, how did you know? I've made a mistake. Smash subscribe before the waggle dance finds you. See you next time.